Did you know that the aluminum used in Coca-Cola cans is so advanced that the same alloys are used to make airplanes? Coca-Cola sells over 25 billion aluminum cans every year, and more than 15 billion of them get recycled. But how does a crumpled soda can turn back into a perfect, shiny new one? We took a trip inside one of these massive factories to track the process from collection to melting. Let's find out. Coca-Cola sells billions of cans every year, and instead of letting them pile up in landfills, the company is on a mission to recycle every single one. By 2030, Coca-Cola aims to collect and recycle a can or bottle for every one it sells. In 2023, it was already recycled 62% of its packaging, which means over 15 billion of its aluminum cans get a second life each year. The journey of a recycled Coca-Cola can starts the moment you toss it into a recycling bin. That one small action kicks off a massive operation that stretches across cities, countries, and even continents. But what happens next? The first step is collection. Across the world, millions of used Coca-Cola cans are gathered through different systems. In the US, many states have redemption centers where people trade in cans for cash, a simple incentive that keeps millions of them out of landfills. In Europe, deposit refund programs work in a similar way. Return an empty can, get a small refund, and ensure that aluminum stays in circulation instead of ending up as waste. And then there's Brazil, the world leader in aluminum can recycling. With an astonishing 98% recycling rate, Brazil proves that when a country commits to recycling, the impact can be massive. Once collected, the cans need to be compressed. Loose cans take up a huge amount of space, which makes transporting them inefficient. So, before they move any further, they're crushed into compact blocks called bales. At large recycling centers, thousands of cans are funneled onto conveyor belts and fed into giant hydraulic presses. These machines apply an enormous amount of pressure, squeezing the cans together until they form dense, rectangular bales. Each one weighs up to 1,000 kilograms and holds around 65,000 cans. Without this step, transporting aluminum would be way too expensive. From here, the bales are loaded onto trucks or rail cars, traveling hundreds or even thousands of kilometers to major recycling facilities like Novelis, the world's largest aluminum recycler. These plants process millions of cans daily, breaking them down and turning them into raw aluminum sheets for brand new beverage containers. In some places, bales are stored temporarily to ensure a steady supply for recycling plants. Unlike plastic or paper, aluminum never degrades, no matter how many times it gets recycled. Once at the plant, the bales don't sit for long. They're immediately fed into massive shredders, 340 horsepower machines that tear through metal like paper. The grinding roar fills the factory as the cans are ripped into small fragments. But this isn't just for show. Smaller pieces mean faster cleaning and melting later on. Sensors track the aluminum flow, automatically adjusting bell speed to keep everything running smoothly. But before the aluminum can be melted, it has to be cleaned. Unlike steel, aluminum isn't magnetic, which means traditional magnet-based sorting methods won't work. Instead, the shredded pieces are sent through high-speed optical sorting systems. Infrared sensors scan every fragment, instantly detecting any material that isn't aluminum, like plastic, glass, and bits of leftover labels. Within milliseconds, high-powered air jets blast these contaminants off the conveyor belt, ensuring that only clean aluminum makes it to the next stage. With this level of precision, some steel fragments may still be lurking in the mix. To remove them, the shredded aluminum passes under powerful magnetic separators. These rotating magnets attract any remaining steel pieces, lifting them out of the mix and dropping them into a separate bin for recycling. Without this extra step, steel contamination could cause serious problems when the aluminum is melted down, weakening the final product. Now comes another challenge: removing the paint and protective coatings. Every Coca-Cola can is covered in branding and a thin lacquer coating that prevents the beverage from interacting with the metal. But those coatings don't just disappear on their own. The shredded aluminum enters massive rotary kilns, where temperatures soar past 730 degrees Celsius, hot enough to vaporize the coatings instantly. As the aluminum moves through the furnace, a carefully controlled airflow ensures that the burning residue doesn't settle back onto the metal. The paint and lacquer are reduced to vapor in seconds, carried away by an advanced filtration system designed to prevent air pollution. Some facilities even use afterburners to break down these vapors even further, ensuring no harmful emissions are released into the atmosphere. This step is crucial. If any one of these coatings remain, they could contaminate the molten aluminum and create defects in the final product. Once the aluminum is stripped clean, it's time for the real transformation to begin. At this stage, it no longer looks like soda cans. It's a shimmering, molten river of liquid metal, glowing at intense temperatures. But molten aluminum isn't as smooth and predictable as water. It's thicker, heavier, and incredibly reactive. The moment it's exposed to air, it begins to oxidize, forming a layer of aluminum oxide on the surface. This byproduct, known as dross, is a dense, foamy layer of impurities that must be carefully removed before the aluminum can be shaped into something new. This is where skilled operators step in, armed with long steel paddles and dressed in heat-resistant protective gear. Using careful, controlled strokes, they skim the dross off the surface, making sure not to waste any usable aluminum in the process. But manual skimming alone isn't enough to achieve the highest level of purity. Recycling plants use a combination of science and precision engineering to further refine the aluminum. Special chemicals, called flux agents, are added to the molten metal. These chemicals attract oxides and other unwanted particles, causing them to clump together and rise to the surface where they can be skimmed away more easily. Some facilities even use an advanced technique involving chlorine gas. Tiny amounts of chlorine are injected into the furnace, bonding with contaminants and lifting them into the dross layer for removal. The goal of all of this purification is simple: produce the cleanest, highest quality aluminum possible before it gets cast into a new form. Once the metal reaches its ideal purity, it's ready for the next step: casting. The molten aluminum is carefully poured into massive molds where it begins to take on a solid shape. One of the most common methods used in aluminum recycling is direct chill casting. This technique involves continuously pouring molten aluminum into a mold while spraying it with water to rapidly cool the surface. The sudden temperature drop prevents cracks, warping, or weak spots, ensuring that each batch of aluminum is uniform and structurally sound. At the end of the process, what started as a pile of discarded soda cans has now become a set of massive, gleaming aluminum ingots. Each one stretches up to 10 meters long, weighs around 27 tons, and contains the recycled metal from roughly 1.5 million Coca-Cola cans. These ingots are now ready for their next transformation, being rolled, stretched, and reshaped back into brand new cans, ready to start the cycle all over again. These massive aluminum slabs are now the raw material for countless products, but for Coca-Cola, they're about to become brand new soda cans. Once fully cooled and hardened, the ingots are transported to rolling mills where they undergo a dramatic transformation. These heavy, solid blocks will soon become thin, flexible sheets of aluminum, light enough to be shaped into cans, but still strong enough to hold pressurized soda. The first step is reheating. The ingots are placed inside massive industrial furnaces and slowly heated to around 525 degrees Celsius, softening the metal just enough to make it pliable without melting it entirely. The softened ingots are fed into a series of enormous rollers which press them down with extreme force, gradually flattening them out. With each pass, the sheets become thinner and longer, extending for thousands of meters by the end of the process. Maintaining consistency is critical. If any part of the aluminum sheet is even slightly thicker or thinner than the rest, it could cause defects in the final can. That's why advanced laser sensors continuously scan the material, ensuring every millimeter is perfectly uniform. If a variation is detected, the system automatically adjusts the rollers to correct it in real time. By the time the rolling process is complete, the aluminum sheets are incredibly thin, just 1/4 of a millimeter, about the thickness of a human hair. But despite their delicate appearance, they're remarkably strong. Now comes the part where aluminum sheets turn into actual cans. High-speed machines get to work, punching out thousands of small, shallow cups from the sheets every minute. These cups then go through a shaping process, where they're gradually stretched taller and thinner as they pass through a series of molds. They need to be lightweight, but tough enough to handle pressure and transportation without bending or breaking. Once the cans are formed, they're far from ready to hold Coca-Cola just yet. First, they go through an intense cleaning process. Any oil, dust, or tiny bits of debris left from the manufacturing are completely removed. But cleaning is only part of the process. The inside of every can gets coated with a special protective lining to keep the Coca-Cola tasting exactly as it should. Without this barrier, the aluminum could react with the soda, affecting the flavor. Not something Coca-Cola would want. Meanwhile, lids are cut from aluminum sheets, pressed into shape, and coated with a rubber seal to keep the cans airtight. Next, the empty cans race down the line. Coca-Cola is poured in, precisely measured, and carbonated for that signature fizz. Within seconds, lids are attached, sealed tight, and ready to go. Packed, stacked, and shipped worldwide, these cans will soon be in stores, vending machines, and fridges. And in just 2 months, they could be back on the shelf, fully recycled and ready for another round. That's the power of aluminum. Endless reuse, one sip at a time. And that's exactly how Coca-Cola recycles over 15 billion aluminum cans each year, keeping them out of landfills and giving them endless new lives while saving energy and protecting the planet. Which part of the process surprised you the most? Let us know in the comments below. If you enjoyed this behind the scenes look, be sure to like, subscribe, and stay tuned for more fascinating factory processes. What if that soda can that you tossed into the recycling bin this morning could be back on the shelf in just 60 days, looking brand new and ready to go again? And that over 120,000 aluminum cans are recycled every minute around the world, fueling a billion-dollar industry that keeps the planet greener while saving massive amounts of energy. From collecting to melting, this is how 100,000 aluminum cans are recycled each minute in a factory. The journey of recycling aluminum starts the moment you drop an empty can into the recycling bin. From that small action, a massive process begins, spanning cities, industries, and even countries. The first step is collection, and it's a key part of this system. In the United States, consumers can take their used cans to redemption centers, earning small cash rewards while keeping millions of cans out of landfills. Europe runs on deposit refund programs and organized community collection drives. Brazil leads the world with an impressive 98% recycling rate, showing how national systems can make a huge impact. Once the cans are gathered, they're crushed and packed into giant bales. Each bale weighs up to 1,000 kilograms, about the size of a small car, and holds 65,000 flattened cans. Without this compression, loose cans would take up too much space, making transportation inefficient and expensive. But when packed tightly into these compact blocks, they're easy to handle and transport. These bales are shipped to major recycling centers like Novelis in the UK, or large plants in Japan, Germany, and the US. Upon arrival, they're stacked like giant building blocks, waiting to be broken down and recycled into something new. If you're enjoying this video so far, make sure to hit that like button and subscribe to the channel for more content like this. From here, the bales are placed on conveyor belts, heading straight for powerful industrial shredders. These shredders come with 340 horsepower and tear through the bales with ease. Inside, spinning blades rip the aluminum apart, shredding the cans into small, jagged pieces. The sound of metal grinding against metal fills the factory, creating an intense and chaotic atmosphere. But this isn't just about making noise. Shredding reduces the volume of the cans, making them easier to clean and quicker to melt down later. Before they can be melted though, the aluminum needs to be sorted. This step is crucial because aluminum, unlike steel, isn't magnetic, so it can't be separated using simple magnets. Instead, the shredded pieces move down conveyor belts at high speed and pass through an advanced optical sorting system. Infrared sensors scan the flow of metal, identifying and removing anything that isn't aluminum. Plastic, glass, or leftover labels. High-powered air jets kick these impurities off the line instantly, ensuring they don't contaminate the clean metal. Even with the optical system doing its job, some steel fragments might still be mixed in. To catch these, the conveyor passes under magnetic separators, which pull out any remaining steel. The process is incredibly fast, but the precision is impressive. What looks like a chaotic blur of flying metal is actually a carefully synchronized system, ensuring that only clean aluminum moves on to the next stage. Now that the aluminum is sorted, it still faces another challenge before it can be melted. The shredded pieces are often coated in materials like protective lacquers on the inside of the cans or colorful paint and labels on the outside. If these coatings are not removed, they can contaminate the melted aluminum and weaken the final product. To solve this, the shredded aluminum passes through high-temperature furnaces built specifically to burn off these residues. Inside the furnaces, the temperature soars past 700 degrees Celsius, hot enough to vaporize the coatings instantly. As the aluminum shreds pass through the fiery environment, you can almost imagine the heat radiating off the walls. The paint and lacquer are reduced to vapor within seconds, leaving clean, bare metal behind. Airflow within the furnace carries away the vapor to ensure it doesn't settle back on the aluminum. This step is critical because even a small amount of leftover residue could cause imperfections in the next stage, smelting. But molten aluminum doesn't cooperate easily. As it melts, it reacts with oxygen in the air, creating a layer of aluminum oxide called dross. This dross floats on the surface, similar to the foam that forms on a cup of hot coffee, but at extreme temperatures. If left unchecked, the dross could mix back into the liquid metal and lower its quality. Skilled operators step in here with long steel paddles, skimming the dross off the surface with precision and care. Skimming dross isn't just about scraping impurities off the surface. It's a combination of science and skilled technique. Modern recycling facilities often rely on flux agents, special chemicals added to the molten aluminum to help impurities stick together and separate more efficiently. Some plants even inject chlorine gas into the furnace. The chlorine reacts with unwanted particles, lifting them to the surface so that they can be easily skimmed away. This combination of manual skimming and chemical refining ensures that the molten aluminum is as pure as possible, ready for casting. Once purified, the glowing liquid metal is poured into molds to cool and harden. One widely used method is direct chill casting, where water sprays directly onto the metal as it leaves the mold, cooling it quickly and preventing cracks or defects from forming. The result? Massive ingots that can weigh up to 27 tons each and measure 10 meters long. It's astonishing to think that each of these giant blocks contains the recycled aluminum from roughly 1.5 million cans. These solidified slabs, or ingots, are the foundation for countless products: new cans, car parts, and even components for airplanes. As they cool, the metal inside becomes dense and strong, creating a perfect base for further refinement. Some facilities take a different approach, using twin roll strip casting to produce thin aluminum sheets directly from the molten metal. But for large-scale operations, casting large ingots remains the preferred method due to their versatility. Once the ingots are fully cooled and hardened, they're ready to be transported to rolling mills for the next stage of their journey. Here, they'll be reheated to around 525 degrees Celsius to relax the metal's internal structure and make it easier to work with. These massive slabs will then pass through powerful rollers that gradually flatten them into thin sheets. It's a bit like rolling out dough, only on an industrial scale. By the time they're done, the aluminum sheets are then as thin as 1/4 millimeter and ready to be shipped off to factories where they'll be transformed into new cans. To put it into perspective, these sheets are thinner than a grain of rice, but strong enough to be rolled into massive reels stretching thousands of meters long. Next, these large reels of aluminum sheets are then sent to can manufacturing plants, where high-speed machines get to work. Cupping presses punch out thousands of shallow cups every minute with remarkable speed and precision. But these cups are just the first step. They're then pushed through a series of forming rings, each one slightly smaller than the last. This gradual squeezing shapes them into the familiar aluminum can, with walls that are thin enough to be lightweight, yet strong enough to hold liquid without bending or breaking. Once the cans are formed, they go through a thorough cleaning and treatment process. Any grease, dust, or leftover particles from manufacturing are washed away, leaving them spotless. But it's not just about cleaning. Each can's interior is treated to prevent any reaction with the beverages it will contain later, ensuring the drink stays fresh and uncontaminated. Meanwhile, the can lids are made separately. Sheets of aluminum are cut into discs and pressed into perfectly formed lids. A rubber sealant is applied around the edges to create an airtight fit, guaranteeing that once the cans are filled and sealed, they stay that way. The pull tabs are molded and attached using precision machines, completing the lid's design. Interestingly, the technology behind this process is closely related to aerospace engineering. The aluminum alloys used to make beverage cans are very similar to those found in rockets, so the can holding your soda is more advanced than you might think. Economically, aluminum recycling is a giant. The industry creates over 100,000 jobs in the US and generates billions of dollars in revenue each year. By keeping materials in use and reducing the need for raw resource extraction, it plays a vital role in promoting a circular economy, This system ensures that products are continuously reused instead of being discarded, reducing waste and environmental harm while boosting long-term economic growth. Finally, after the cans are formed, cleaned, and sealed with their lids, they're ready for their final journey. They are then filled with soda, beer, or other beverages and shipped to stores around the world. The cycle doesn't stop there. In just 60 days, the can you're holding today could be collected, melted down, and reborn as a brand new can, clean, shiny, and ready to start its journey all over again. That's the beauty of aluminum. Endless recycling, endless possibilities. And that's how over 100,000 aluminum cans are recycled every minute, giving them endless new lives while saving energy and protecting the planet. Which part of the process surprised you the most? Let us know in the comments below. If you enjoyed this behind the scenes look, be sure to like, subscribe, and stay tuned for more fascinating factory processes.